Okay, so this part of the workshop is actually going to be more, I hope it'll be more interactive. It's not so much a lecture, so much as me trying to help you develop some skills. So you don't have to wait till the end for questions. Please stop at any time and ask whatever question you want. So, as I said, I am what's called a learning assistant. It is not something you can San Jose State University. It's actually a program that is implemented in a lot of universities in the US. I pulled this from Wikipedia. It says learning assistants are undergraduate students who, through the guidance of weekly preparation sessions and pedagogy course, facilitate discussions among your students in a variety of classroom settings that encourage active engagement. That's a lot. Put simply, we are tutors, but we work in the classroom. So a normal day for me as a learning assistant, I'm in a class like this. Actually, no, I'm in a class with about 100 to 120 students, so really big. And there's an instructor giving a lecture like normal, but in classes with learning assistants, they do a lot of, well, not project-based learning, but a lot of the lectures aren't the teacher giving students information. It's a lot of students being given a question and discussing how they want to solve it. So a learning assistant, their job is not to go to the students and tell them the answer, or tell them if their answer is correct. Our job is to go to the students, listen in on what they're discussing, and then see if it makes sense. If the students have some good ideas, we try to make sure they keep going with those good ideas, make sure they have more good ideas. If they're not too sure on what they're doing, guide them into finding some more good ideas, or if their ideas are kind of wrong, but kind of right, we try to steer them towards the more correct part of their ideas. So it's very much not based on getting the right answer, it's very much based on helping you learn. So that ties in very well to this workshop because, like we said earlier, the goal of this isn't to teach you calculus or business concepts. It's very much about problem solving techniques. So again, let's just go over what we'll be covering. Again, please stop me if you have any questions. So first, the first 4 of these are part of the process I will be explaining. So first is understanding the problem, then setting it up, then answering the problem, and then checking your work. These are mostly for work. So they're going to give you like a scenario, like they're going to describe an event and ask you to do some kind of math based on it. And then the last 2 are just like giving you a few more tips. The last one is just questions. So first is understanding the problem. And actually for this, I have some worksheets. It's a quick exercise that I want you all to practice. I don't know if the students on Zoom will be able to do this. So we're going to give, I think, 5 minutes for this. It's not difficult. There's actually not too much math involved. It might seem weird, but and can you pass it up face down?
Pass it face down.
So don't look at it yet. So this exercise isn't too much math, and it might seem weird, but I promise there's a purpose. Does everyone have a paper? Raise your hand if you don't have one. Okay, so I'm not going to describe what this exercise is. The instructions are all there. You will have 5 minutes to do this. Everyone ready? Okay, go. Also, please do this by yourself. Do not discuss this with your classmates. And for those on Zoom, I will explain the exercise once it is finished. So you'll touch that. About 2.5 minutes. One of the instructions is to say something in English, but you can say it in Tagalog. We have about 1 minute left. Ethan. 30 seconds. I have. Yeah, right. I have. The first person to reach this one and I'm delivering That's time. Okay. So, if done right, everyone should have finished by now. Can you raise your hand if you did not finish? In the last direction on the page. Let's see. Let me call CJ. CJ, can you read the last instruction for me?
At 1 and 2 and 1 and 2. Keep these so that others will continue to read without disturbance from you. Do not make any sign to give a whole. Clear having completed.
Thank you. So, can someone read the first instruction to me? Let's see. Trisha, can you read number 1 for me? Okay, thank you. So, we here read everything before doing anything. Okay, so it's all right. I've done this before too, and I also failed. So that is what we're going to start with. So for those of you on Zoom, this worksheet had, was it 22 questions? The first question said, please read everything on, wait, is the English? Yeah, read everything carefully before doing anything. Meaning, read all the instructions before doing any of them. And then the last instruction basically said, do not do any of these except for 1 and 2. So if you notice people standing up and saying, I have on the first person to finish, they actually weren't supposed to do that. Yes, they were instructed to, but they are also instructed not to do that. So that takes me to why this is important. So first of all, you can't solve a problem if you don't understand it. So with the word problems, there's a lot of information. You need to understand what's going on, and to do so, you need to read the instructions carefully. So the next point is that this will save you time. I said that if done correctly, everyone should have finished this. 5 minutes is actually plenty of time. I understand this is in English, so it might take a bit longer to read, but I think it could have been done in 5 minutes, given you only had to write your name. So yeah, in math and physics, if you miss information in a word problem, it often comes back to bite you. You'll be missing information, and then when you find out your answer is wrong, you have to go back and fix it. So knowing what you're doing ahead of time and knowing all of it is very important. And then, yeah, again, missing information, it just makes it more difficult. So for this workshop, at least for the lecture portion, I want to, and again, please ask any questions if you have any. And actually, before I go on, did you all enjoy that activity? Yeah. I was given this activity in high school and I thought it was really fun. I was one of the first to actually do the more crazy things. Like, I think the one we had to like get up and do jumping jacks or something. It was weird, but I think this is a really good exercise to do. So yeah, for this workshop, I'll be going over a problem and then walking through how I would approach the setup. So the problem here is an engineer is designing a runway for an airport. So think NIA. Of the planes that will use the airport, the lowest acceleration rate is likely to be 3 meters per second squared. The takeoff speed of this plane will be 65 meters per second squared. Assuming this minimum acceleration would be allowed length for the runway. So that is a lot, but simply, let's just say you have a plane or you have an airport. They're trying to make the runway, so when the plane goes across, when it starts to take off, and they want to know how long it should be so that the plane doesn't crash before it starts flying. And we're given information here to help us do that. And can I just get an idea, who here is familiar with physics terms like acceleration, velocity? Can you just raise your hand? It's okay if you don't, just want to have an idea. Okay, so no one. That's okay. So like I said, these might be concepts we haven't gone over. I will cover them as we go. But the main idea here is problem solving. So again, feel free to ask questions. Okay, so this first portion is just understanding our problem. So we have the problem here and we want to break it down. So first, what is the question asking? Can anyone tell me? If no one raises their hands, I'm going to ask for volunteers. Oh, sorry, not ask for volunteer, I'm going to volunteer someone. Okay, I'm going to call someone. Jericho. What do you think? Just take a guess, it's not to be right. You don't have to tell me in terms of math, just what do we want from this? The length of the runway. Exactly. Usually it's in the end of the question. They always put the word problems always have the question at the very end. So how long should the runway be? Not too hard, right? Everyone follows so far? Good. Thumbs up. Okay, let me know if you're getting lost. Okay, now, what do we know? Does anyone have any ideas? Again, you don't have to just throw it out there. What do we know? What does this problem tell us? What information? You can just read off the problem. That's not what I'm thinking. I'm going to start calling again. No one wants to volunteer. Okay. Wolf, what do you think? If you want to come up closer, we can.
The lowest acceleration is 3 meters per second squared.
Exactly. Good. Anything else?
And
Yeah.
the speed is 65 meters per squared.
Perfect.
Meters per second.
Perfect. Do we have anything else? Okay. So yeah. Right there. Again, understanding the problem is just reading it. There's nothing tricky here. The only tricky part is if you read too fast or go step by step, you might miss something. So yeah, we have what we're asking and what we know. So both of these will be very important very soon. So part 2 is setting up the solution. So I imagine with a lot of you, when you see a word problem, what is the first thought that goes through your minds? There's no right answer, just what do you think when you see a word problem? That's with a lot of words. You can raise your, yes. It's hard, okay. Any other thoughts? Oh, actually, what part about it? Oh, okay, so it's a lot of information, right? Okay. Any other thoughts? Okay, that's good, but yeah, honestly, same. I see these problems and I'm like, oh my God, that's a lot. I can't do that. So, like I said before, break it down. A lot of times these problems are way simpler than you think. Like the problem I showed you earlier, the old me would have had the same reaction. But me now, I'm like, oh, they're just asking how long the runway needs to be. Really simple. So it might seem like I know what I'm doing, but realistically, it's still something I have to practice, but it's something you can all learn. So I'm going to introduce you to something that I learned in high school that I still use to this day. It's a method called guess. And no, we're not going to guess the answer. We are going to guess the answer. Just not the way you think. So, guess is actually an acronym. Can anyone guess what guess stands for? Any of the letters? I'm not going to call you out on this one. I don't expect anyone to know. Any ideas? Exactly. G stands for given. Sorry, what was your name again? Venice. Thank you. Okay. Any other guesses? Yeah. Unknown. Perfect. And what was your name again? Kristen. Thank you. All right. Any idea for E? Perfect. Equation. The first S. Anyone know? I'm hearing a lot. Can someone raise their hand? Yes. Kristen? Close. Any other guesses? This one might be a bit harder. Any other guesses? This first F means substitute. I'll explain what that means later. You might be able to guess, but I'll explain later. And then what do you think the last S stands for? Solve. Perfect. All right, so yeah. Can anyone see why this would work? Does anyone have an idea what this does? Anyone? You sound like even we seemed like this. Sorry. Okay, it's fine. Okay, so let's apply this to the problem we're doing right now. So again, I just made the question much simpler by going over what we did earlier. So again, we're asking how long should the runway be? And we know that the slopes plane accelerates at 3 meters per second squared, and the same plane needs to reach 65 meters per second to take off. So what's our given? Can anyone tell me? I will be calling on people for this if no one volunteers. Sorry, what's your name? Yorenz? Is that the right pronunciation? Is that did I pronounce it right? Yorenz. Okay. What do you think we have as our given? What is 3 meters per second squared? What does that represent? It's okay, we don't know. Acceleration. So our acceleration, I spelled them. Okay. Our minimum acceleration is 3 meters per second squared, and our final velocity is 65 meters per second squared. I know you all said you aren't too familiar with physics, so I will briefly describe what those are. So actually, let me write, because another thing, problems, write it down. Don't do it in your head. That's where all the mistakes take place. So especially with guests, I like to actually write the board or where I'm working each part. So for givens, we have acceleration. I'll use A for that. So what acceleration is, if you think of like a car or a motorcycle, it's how fast it's speeding up, if that makes sense. So actually, let me describe velocity first. Velocity is the same thing as speed. So if you look at the speedometer on your motorcycle or car, you'll see that it says like 5 kilometers per hour. That's how fast you're going in a certain direction. So for our purpose, that's what velocity is. And then acceleration is how fast that speed takes up. So 3 meters per second is basically saying that every second you're going 3 meters faster. Does that make sense? Thumbs up, thumbs down. Okay, so we have a minimum acceleration of 3 meters per second squared. And let me know if I need to write bigger. And then our velocity or our final velocity is, so I'll actually write df, this is final velocity. It's going to be 65 meters per second. Okay, so that's our givens. Now, what's our unknowns? Can I get anyone to tell me? Sorry. Don't be shy.
The runway.
Runway, what about the runway?
How long should?
How long? Okay, so we call, so like, sorry, I'm terrible with names. Avon? Like Avon said, our unknowns would be the runway's distance. So we'll represent that as, in physics, we describe distance as what's called delta x. Actually, no, that's displacement. We'll use x. So x is our unknown. X equals, let's put a question mark for unknown. That's what we're trying to find. Now, okay, so the next step is what? Okay. The next step is equation. So I have 4 equations up here. Since I know you have physics, I'll just give these to you now. I don't expect you to understand why these equations are what they are, but looking at what's here and based on what information we have, actually, let's put it to a vote. I'll give you a couple seconds and tell me which one we should use, or we'll have a vote. So I'll give you a few seconds for that. And just for a little more extra information, if it's just V, the V is the same thing as V final, and then VO means the initial. So basically that's saying the starting speed. And then VF is again final speed. Okay, give you a few more seconds. Okay, we ready? Raise your hand if we think we should use equation 1. Okay, equation 2. Okay, few people think equation 2. Can I ask one of you why do you think it's 2? Don't be shy. What was your name? Sorry, I can't see your name. Sorry. What's your name? Sorry, say again. Okay, so it equals to x, which is what we want. That's a good start. Okay, we'll think about that. So maybe we use 2. Raise your hand if you think we should use number 3. No one? Okay. Number 4. Okay, so we're just not sure in general. Okay, no problem. So let's go through one by one. Let's see. Let's start with 2 actually, because some of you said 2. Do we have x delta? Let's just say delta x. Do we have an x value? No, but we want to find one, right? Okay, so that checks out. We can use so for number 2, we need an x, and that's what we're looking for. So that's okay. Do we have v0? Raise your hand if you think yes. Do we have a starting speed? Are we given a starting speed? Okay. Raise your hand if you think we don't have it. Raise your hand if you think we don't have it. Okay. Here, let's do it this way. I'll go back to the problem. Oh. Okay. Is an initial speed or initial velocity in our givens? No, right? So do you think we don't have V0? Danleo, what do you think? No. Okay. I can see why you would say no. And oops, that's actually not the case. We do have an initial speed because if you read the problem, it doesn't tell you that. But keep in mind, these word problems represent real life events. Have any of you actually seen a plane take off a runway, either in person or through a video? Yeah. What speed does the plane start at? 0. Perfect. So we do actually have an initial velocity. So let's add that to our givens. Okay. Sometimes this method helps, but it's not the only thing you need. problem solving involves critical thinking. You need to read a problem and not only understand what it's telling you, but do what's called reading between the lines. You need to understand what, sorry, you need to understand what they're telling you without telling you directly. So that's not easy. And I can't teach you how to do that. It's just a skill you have to practice. And that's why we're doing this, to practice. So actually, let's keep going through this though. We have V0. Do we have A? A is acceleration. Do we have an acceleration? Wait, sorry, I'm looking at the wrong problem. We're doing two. So we have V. Do we have V? Yes, we have V. That is 65. Yes, thank you. And I will say, always write your units. That will help you later on. And then, like you said, we have V0 and 0. Do we have, well, 2 is what we call a constant. If you see a number in an equation, you don't need to worry about it. And then do we have T? Does anyone know what T might stand for? Time. Do we have a time? No. Are we looking for time? No. So T, we don't have it. So we can't use 2. All right, let's try the other ones. How about 1? Do we have a final velocity? Yes, we have 65. So 1, we have 65. Again, if I'm going too fast, please stop me. Do we have V0? Yes, no? Yes, it's 0. And then acceleration? Yeah, we have 65. I'm sorry, did I put 65 here? That's supposed to be 3, I'm sorry. And then do we have time? No, we do not have a time. So we can't use 1 either. And I'm not gonna write the rest. Let's just go through the other ones. 3, do we have X? Or are we looking for X? Yes, no, thumbs up, thumbs down. Okay, we don't have X, but we are looking for X. So that is there. Do we have V0? Yes, we have V0. Do we have time? No, so we can't use 3. So we can probably use 4, let's check. Do we have V? Do we have V0? Do we have A? Do we have, or are we looking for X? Yes? We don't have X, we're looking for it. So yeah, so long story short, when you're trying to choose an equation, you need to decide, well, first you have to decide what set of equations to use. In physics, these are called the kinematic equations. They basically describe motion. So because we're talking about distance and velocity and acceleration, we use this set of equations. You'll be going over this once you take physics, but for now, I'll be helping you through that process. Okay, so we have determined, because we have all the variables we need, we can use equation 4. So for E, our equation is V squared equals V squared 0 plus 2A, I'll just use X instead of delta X. Okay, does everyone get that so far? Any questions? Okay, we have a lot of time, so don't be afraid to ask a question. Oh, and then, yeah. So again, just note that the starting velocity is 0 because a plane starts at what we call, if we say it starts at rest, meaning it's something that needs to be practiced. Okay, so now we actually answer the problem. Does anyone remember the next step of guess? Substitute, perfect. So let's do that. Can anyone guess what that means? Aiden? Distribute, can you explain what that means?
By getting the
Perfect, yeah. So you take the given information and put it in your equation. So let's do, I'm just gonna do SU. So substitute, excuse me. Let's see, our equation is V squared equals V initial squared plus 2AX. Now, what's our V? 65? Yeah, 65. And then what's our units? Meters per second. Always remember units. Okay. Equals, and then what's V initial? 0 squared plus 2. And then I like to use parentheses just so I can separate my variables, especially in multiplying. What's A? 3 meters per second. Perfect. Wait, oh, meters per second squared. Cool. And then what's X? We don't know. Perfect. Okay, cool. And then what's the last? And then what's the last step? Solve, right? Okay, so does anyone want to come up and solve this? Yes? Oh, yes, thank you. Thank you for pointing that out. That's often when you get a problem wrong, that's what happens. You have to be very careful. Thank you. So again, I'm not perfect. If I make a mistake, please tell me. Okay? All right, so does anyone want to come up and solve this? Don't be shy. You don't have to be right. Just try. Jericho, you sound interested. You sure? Come on. Okay. All right. Can someone tell me what we can start with? What should be our first move? Okay, so it shouldn't be too difficult. Any ideas, Jericho? Okay. Does anyone know what we can do with the 0? Cancel, yeah. Usually when you see a 0 in a problem, especially being multiplied, just ignore it, honestly. I am so sorry. So cancel the 0. Okay, so we can rewrite this. 65 meters per second squared equals 2, 3 meters per second squared. I apologize for my handwriting. And then times x. Okay, any ideas what comes next? Just take a guess, doesn't have to be right. Chelsea, is that your name? Any ideas? Move x to the other side. Okay, so you want to move the 65 to this side and the x to the other side. Okay, how would we do that? It's okay. It's a good start. You're right. You're right. Just how do we do that? Change the sign. It's okay. It's okay. That's okay. No worries. No worries. It happens to all of us. Sorry? Division. Perfect. Okay. So we divide this side by 65 squared. And then divide this side by x. Okay, we can do that. That works. Okay, so what does each side become? Actually, you know what? I'm gonna make this too hard. You're right about moving to the other side, but okay, actually, what will we get if we did this? Can anyone tell me? Okay, what happens to, what's on this side? Does anyone know? What happens when we, so let's pretend this wasn't here. I crossed it out because we're moving it to the other side. So what does this become when I remove this? It becomes a 1, right? Everyone got that? Okay, so now what's 1 over x? This is 1 over x. That's the other thing. Sometimes don't think too hard. Sometimes the answer is right in front of you. Just don't overthink it. So 1 over x. Cool. And then what's on this side? It's already there. We don't change anything, right? Just remove the x. Does everyone get that? Okay, cool. So actually, let's just make it quicker. What's 2 times 3? 6. So now we have 6 meters per second squared. Perfect. And then that's over. Can anyone calculate 65 squared just to save us some time? Yeah, once you get to physics and math, I'm not too sure if your instructors let you use calculators, but yeah, in higher level math, you're gonna need a calculator for stuff like this. Don't be afraid to use it. Sorry? 4,225? Okay, and then, oh, here's an interesting, let's see. What do you think the units become? Because remember, you square everything. Sorry, can one of you speak up? Sorry, say again? Yes. Perfect. Meters squared per second squared. All right, perfect. So now we have this. Does anyone know how to solve this? Okay, can we just flip them? Okay, so if you didn't know, if you have 2 fractions, you can just flip them and they'll equal the same thing. It's the same thing as multiplying x and then multiplying 4,000 works, but let's just say you can flip them. So yeah, I'm really close to the speaker. I'm scared to talk into the mic. So you'll end up with x times 4,000 over 6. So 4,000 meters per second squared over 6 meters per second squared. Did I miss something? Okay, it's okay. Okay, so that's almost there. Can anyone tell me what looks wrong about this? Actually, sorry, never mind. Forget I asked. Okay, so what's left here? Division, right? Can anyone do this math for me on their calculator? Oh, also, let me put solve here. Anyone got it? Sorry? 700. Oh, 747? Okay. So 74.7. Oh, 704. Okay. 0.78. 17. 17. Okay, and then that, what happens to the units? Meters, perfect. All right, let's see. Oh, yeah. So sorry. Yeah, basically the same thing. It's just rounding, but yeah, that's close. I do want to point one thing out. So dividing x here and dividing 65 here, that's not wrong. We got the right answer. However, there's also another way to do this. Is it okay if I erase this? Does anyone else need this? Oh yeah. Okay, so let's go back. We had 65 meters per second squared plus 2 times 3 meters per second squared times x. Okay, does anyone know what else we could have done in this situation? Anyone? Okay, that's fine. What we also could have done was divide. Actually, let's make this 6 just to save ourselves some time. So let's say 6. We also could have divided by 6 meters per second squared. So cancel, then divide 6 meters per second squared. And does this look familiar? So this becomes x equals 65 meters per second. Oops. Squared over 6 meters per second squared. Does that look familiar? Where have we seen this before? It's right there, right? Well, we squared it already, but it's the same thing, right? Yeah, so this is also a correct way to solve it. That's another thing to know about problem solving, especially in math and physics. There's always multiple solutions. There's not one right way, which brings me to, actually, that's going to come up later. Sorry. Okay, what comes next? Validating our solution. So I'm not too sure if you know what validating means, but it essentially means checking if you're right. So there are various ways to do this. Before I show you, does anyone know how we can check? Just throw ideas out there. You don't have to be right. And you might have an idea that I have never heard of, which is a good thing. Anyone? Also, I know I went through that pretty fast. Does everyone understand the previous solution? Okay, just let me know if you don't so I can clarify. Okay, yeah, any ideas for checking solutions? Okay, who have I not called on? Heidi, what do you think? Any ideas to check our solution, see if it's right? No ideas? Okay. How do we do this? Anyone else? No one? Okay. How many people are in this room? There's like at least 30 of us. Yeah, 20 kids. There's more than 20 of you doing this problem. If you all got the same answer, what do you think that means? It means it might be correct. If everyone's getting the same answer, you're probably doing something right. Or you all did the same thing wrong. But most of the time, if everyone gets the same answer, it means you're doing something right. So that's one way. Do you remember how earlier I was trying to ask you what was wrong about that? Why do you think I did? This is a bit of a trick question. It's okay if you can't answer it. I was looking at the units. So for a second, I was concerned that those didn't cancel out, but then I realized that they weren't supposed to. So, but that's another thing, checking your units, what's called a unit check. Going through the equation without the numbers and just the units is actually a good way to make sure you're using the right equation. So that's another method. So, like I said, what question should we be asking? These are the 4 I came up with. There are a lot more solution checking methods you could use, but these are the ones that I usually go with. So first, does the answer even make sense? So I'm going to be honest, I use miles, so I don't know how long 700 meters is. Does 700 meters seem long to you guys? It's pretty long, right? And are airplane runways long or short? They're pretty long, right? So do you think the answer makes sense? Like, not even thinking about like if the answer itself is right, does it make sense for it to be that long? Thumbs up for yes, thumbs down for no.
For reference, I think 1 mile is 1.6 kilometers.
Okay. Yeah, but yeah, what do you guys think? Is that makes sense, right? Let me put it this way. What if our answer was, what if our answer was 5 meters? Does 5 meters make sense? Does negative 3,200, that's not even a number, 3,020 make sense? For context, a negative number in distance means you're going the other direction. Does that make sense? No. So just look at your answer. If it makes sense, then you're probably doing something right. And again, do the units match? Do our units match? Okay, actually, I'm going to go over an example of a unit test. So if we take our equation, and sorry, am I going too fast or are you all okay? Thumbs up, thumbs down? Cool, okay. So let's take our equation, v squared equals v0 squared plus 2ax. Actually, no, let's do it this way. I forgot the square last time, so let's try that. So for a unit test, what are the units of velocity? Let me show you the givens. What units do we have for velocity? Meters per second, okay? What about for initial velocity? Same thing, right? Oh wait, I just realized this is still gonna work out. It's okay. So, actually no, I was wrong. Okay, and then we can ignore the 2. 2 doesn't have units. What are the units for acceleration? Meters per second squared. Okay, and then what are the units for x? Meters, perfect. Okay. So let's just do math on these units. What happens when you multiply meters per second squared by meters? Sorry? Squared. Okay, and then what happens here when you square meters per second? Meters squared per second squared. And then when you add those 2, what do you get? 2 times it, right? So we're not worrying about constants, so we'll just say meters per second, or meters squared per second squared. And then what is this? Meters squared, right? Or sorry, meters per second. Does that match? Like, do these 2 match? Do they equal each other? Thumbs up, thumbs down. Okay. Is meters squared equal, sorry, meters per second equal meters per second squared? Are those the same thing? Don't overthink it. Are they the same thing? No. Okay. So when you pointed out my error earlier that I didn't square the V, if I had done this, I would have realized that. Because if I square this, you said that meters per second squared is meters squared per second squared, right? Now does it match? Yeah. So that's actually a really good way to check your equation. Usually one of the biggest errors people make in problem solving isn't that they don't understand the question, they just forget to write something. So if you're like me and you forgot to write the squared, this is how you can check that. Okay. And then, like I said, did you get the same answer as everyone? So I noticed a lot of you were writing the solution yourself, and there was a lot of discussion. Did anyone get a different answer? No? Okay, that's fine, good. If you all have the same answer, then probably means is you got it right. So that's good. And then, can you explain how you got your answer? Can any of you explain how we got this? I'll give you a hint. It's right here. We explained it. Does all this make sense to you? Like as you were doing it? Yeah. So if you show your work, it doesn't mean you got the right answer, but it means it probably makes sense to an extent. Let's say I had this question, and then as soon as you gave it to me, I just wrote 8,025 meters. How do you know I'm right? Do you think I'm right? Do you believe me if I said that? No, right? There's nothing to prove it. But if I gave you 704 and I showed you all this, now do you believe me? Yeah. So show your work. And more than that, this actually involves my work as a learning assistant. I don't know if they have this idiom here in the Philippines, but there's a saying in the US that goes, you know you've mastered a skill once you can teach it. So if I can explain all of this to you, it goes to show that my answer probably makes sense because I can explain why it makes sense, okay? So don't just assume you're correct. Always look back and check your answer. This is actually really important for exams because depending on the format, because some of the exams I took, you can just, you get multiple tries and they'll tell you what's wrong. But most of them, they don't tell you. You get it wrong, you don't know, too bad, you're done. You lost the points. So checking your work is always very important. Sorry. Okay, so all the same things. So our answer was 704. Does it make sense? Yeah, the runways are pretty long. Let's see. Do the units match? We already did our unit check. So, yep, just substitute the values and check. And then can you explain the answer? Like I said, if you show your work, oh yeah, so like I said, you show your work, shows that you know what you're doing, but also this is important for problem solving. I told you at the beginning, write down your work. That's not just because, at least in the US, a lot of professors want you to show it or you actually don't get credit. The reason they do that is because one, it's to prevent cheating. So people know you didn't just memorize the answers, but it's also to show that you understand the material. A lot of classes in the US these days, when it comes to math, they don't care if you have the right answer. They care if you can show why it's correct. There's a whole class called discrete mathematics where the whole point is to prove why something exists. One of the problems I had in that class was let's see, if you have like a number and you add 1 to it, why is that number odd? We had to prove why that was correct. And believe me, it was not as easy as you think. But problem solving involves more than knowing the answer. It involves showing your work and knowing why your answer is correct. That's the critical thinking aspect. And as a learning assistant, I'm actually taught to not learn the answers, and I'm taught to not give answers. I always talk with my professor before class to go over the material, but she'll never give me the right answer. She'll always tell me, okay, this is the material and this is where people tend to mess up. From then, when I go into class the next day, I go to the students, I watch them solve the problem, and as they solve the problem, I solve it myself and see if my ideas line up with theirs. Because my job isn't to give them an answer, my job is to help them solve the problem themselves and give them those ideas. And with problem solving, like I keep saying, I can't teach you how to solve problems, but I can teach you how to approach a problem and help you practice solving problems. And this goes far beyond math and physics. In real life, this can help you. Knowing how to identify what a problem is, what needs to be solved, and then what methods must be used to solve it. That's something that will help you just in your life, whether it's academics or just in social situations. So now is just my own tips and tricks. So this is a very simple statement. If it works, it works. Remember how I said earlier, that solution wasn't incorrect, but then I showed you this? Yeah, showed you this. It's what this saying is, what this phrase means is there's not one right answer. If you can explain why it works, then you don't have to worry about having the same process as others. This applies specifically to programming in my course as a software engineer. When we write code, there are hundreds of ways to do it. And half the time, my code isn't actually correct. Like there are things I shouldn't be doing in the code I write, but it still does what it does what it needs to do. And sometimes we have a deadline, whether you're working or you're a student, you have to meet deadlines. And sometimes there's going to be problems. But for the sake of like demonstrating that it works, you can just show that initial not so perfect program and say it works. This is basically saying don't overthink it. If it works, don't try to explain, don't try to fix what doesn't matter. Just make sure it works, you're good. And again, problem solving, the whole idea is not, it's like the saying, it's not the destination, it's the journey. You don't care too much about the answer. You still want the right answer, but the way you get there, the process used to solve it, that is actually very important. Okay, so how do I improve my problem solving skills? So these are my, this is how I personally do it. Practice, I've taken more math classes than I care to mention. And this is a skill, like I said, I learned it in high school. I learned it, how long ago was that? I learned it right after I came back from the Philippines last time. I learned it 5 years ago. And I've used it in every single math and physics class I've taken since then. This method of guess, it's extremely helpful. Knowing these skills and just practicing them over and over has helped me solve problems the way I do today. Next is teach and tutor others. I mentioned that part of why I tutor isn't just for the money, but it's to practice. When I work with students, I have to go through problems I did. The classes I tutor are classes I've already passed. Most students, when they take a class, especially a math class, they finish it, they get an A, and they say, goodbye, I'm not gonna do this ever again. But you tend to forget. And you don't just forget what you learned in that class, your problem solving skills get rusty. So teaching and tutoring others not only shows that you understand how to solve problems, but it helps you practice and develop those skills even further. And in my position as a learning assistant, though I'm not expected to know the answers, I'm expected to know how to find a way to get those answers. So putting myself under pressure to have those skills helps me develop them even more. And again, please, I know I'm going a little fast, so please stop me if you have any questions. Never ask for just the answer. Like I said, in math and science, we care more about if you can explain your answer. So when students ask me, is my answer correct? I tell them, it sounds right, but I don't know if it's correct. Because if you just care about getting the answer, you're gonna develop your problem solving skills. You need to make sure you're developing intuition and practicing those skills rather than just trying to pass your class and get the right answer. Because one thing I didn't realize in some of my earlier classes in college is that I was just trying to finish the assignment and get to the weekend. But in doing that, I didn't practice skills. And when I took more advanced classes later, I was struggling. I didn't know how to do what I was supposed to be doing. So it's really important to practice the problem solving skills and not just to worry about getting the right answer and finishing the assignment. And take your time. Again, I forgot the square. So, and you had to correct me. Had you not corrected me, we would have gotten to the end, gotten the wrong answer with the units that didn't make sense, and I would have embarrassed myself in front of you. So, yeah, and it would have taken even more time to solve. So take your time, make sure you have covered all your bases, make sure you understand the problem and you're doing everything correctly. This is also very important on exams because a lot of the exams I've taken, I didn't feel it because I didn't know what I was doing. I lost points on my exams because I ran out of time, because I messed up on problems, had to go back to the beginning. I had, we had this thing called the AP exam. It is basically an exam you take in high school that you can use to get credits for college and skip some classes. I absolutely failed my AP exam for calculus because there are only 2 questions, but they were the questions that go A, B, C, D, E. And then if you get A wrong, you also get B wrong, and then C wrong, and then so on. Because the information you get in question A is information you use in the following questions. So if one is wrong, the rest is wrong. I got A wrong and it cascaded all the way down. And because I ran out of time, I couldn't fix A, so I couldn't fix the rest. I lost every single point on that exam. So take your time. You will not regret slowing down, because if you rush it, you're going to spend even more time fixing your mistakes. And don't be afraid to make mistakes. I made one right now. We're human, we make mistakes. Just don't be afraid to make mistakes. Part of problem solving and learning that process is just being okay with that failure. What's important is that you learn from it and figure out, okay, I make this mistake a lot. I should probably do something about that. So don't be afraid to make mistakes and make sure to correct them once you recognize those mistakes. And that's about it. Now it's just if you have any questions. And also, how are we on time? Supposed to go to noon. We have about 45 minutes. So yeah, and if you don't have questions, we could start like the practice early. I don't know, how do you want to do this? But let's do questions first. Does anyone have questions? I hear some of this. Some people, it's okay, you can speak up.
Okay, first of all, did it go well? Because I want to know that it went well, but I can't tell.
I had a lot of mixed reactions, so I'm hoping I didn't go too fast.
Yeah. May mga tanong po, questions for the speaker? Kahit po via Zoom, you can key in your questions. I want to like know for sure that it went well.
Yeah.
But like all of it is over my head. So. So I trust our students to know.
Do you feel ready? So most of you haven't taken physics yet, right? This is a basic physics problem. Do you feel like you're more ready for when you do take it? Don't worry, the next session will be practicing this. So you'll get a lot of practice.
So we have grade 11 students, or they've already graduated from grade 11. And we also just say graduation, right? Fifth grade graduation.
Yeah.
And you finish fifth grade. Yeah, so they just finished their 11th graduation and they're going to be facing these things in August. So for our upcoming 11th grade STEM, it's something to look forward to, but definitely the critical thinking aspect of problem solving per se is transferable to any course and any life situation. What about our teachers? Any questions, feedback?
I also know that the teaching style here is a bit different, as Zeke told me. Do you think this is still worth learning the way you teach physics or calculus, I guess? Well, if not feeling ready, does this method make sense? Yeah. Do you think you'll use it when you get to your future classes? Yeah.
There's a maybe.
Well, it doesn't work for everyone. Everyone has their own preferred method. I just really like using guess.
Okay, what about in our Zoom? Do we have questions that are coming in? Do you have questions coming in? Sir Harry? Zoom? No? Yes. Oh, we might have a question.
Oh, interesting. Yeah, I think guess is really just a way to like identify the problem solving process. A lot of schools will still teach you how to take the givens, take the unknowns, find an equation and solve. This is really just giving it structure, and especially students who are very daunted by word problems. This is a way to help them break it down. Because for me, I don't always write GUESS. I just say, okay, I have this information. Let's write it down. I have this information. I need to use this equation, and then go. I do it all intuitively. But for someone who really struggles, having this breakdown is really helpful. That's why I like using it.
I will have to concur with our teacher from JRI because I don't remember the last time that really did math this intensely. Maybe during the first year of practical nursing. I used to be a nursing student, but yeah, I would agree with that because I remember, and even back in elementary school, my days in elementary school, whatever those days were, I think there's like a pattern, a set of questions we answer, like what is asked, what is given, how do you go around this?
Yeah.
So maybe it's not in the guess acronym, but the prevailing logic is there.
Yeah.
Yes.
I hope this wasn't too repetitive in that case.
Actually, for me, it's not. What about for you? Do you find this helpful? To our folks in Zoom, do you find this helpful? Please respond with a yes or a no. What about to our grade 10 students? Okay.
Yeah, I did feel like this, like in concept, this is very simplistic. However, at least back in the States, the students I do work with, very few of them know how to do this. So I figured it was worth talking about, because other than this, like you can't teach problem solving. The only thing else I can think of this was probably the best thing I think I could have spoken about.
Yeah, and yeah, about the teaching style in this space, just so everyone is familiar, we kind of build things from the ground up, right? So like here, it would be normal to sometimes just provide the formula. Or me, I'm a writing teacher. Sometimes the easiest thing to do is to give the format and then just ask you to write. But in the States, usually the teaching style is to do things as we go, just to learn things as we do them. So it might be a little laborious in the beginning, but when you practice it a lot, it's a muscle, it becomes a skill that is just, that you just take with you for the next problems or situations you have to overcome and solve. Okay, I think, are there questions? Any more questions? Okay, if there are no questions, I think we have enough time for another problem from the other worksheet, right? Maybe for the first problem there. But if, with your permission, I would like to mix things up a little bit. Because we know we have 10th graders here, we have 11th graders here. So where are my 10th graders? Or yeah, 10th graders. They just graduated grade 10. Okay, so please go to that side of the room. Over that side of the room. Okay, where are my 11th graders? Okay, to that. Well, stay where you are. Okay, no, go, all of you, okay? For my 11th graders. Okay, this is what we're gonna do. Okay, stand, how many are you? Grade 10. You didn't have to go that far. Okay. You don't have to go that far. Yeah. All right, how many are you? Let's count. 2. Oh, so sorry. Okay, 3, 6, 7, 10, 14, 15. 15 in grade 10. How many grade 11 students here? 9. So maybe we can have one grade 11 student for, oh my gosh, these are math people. I don't want my ratios to go wrong. Like maybe 15 and then 9, maybe. Some will have a partner, some will have a couple of grade 10 students to work with. Okay. Yeah. Oh. Okay. All right, so maghihiwa-hiwalay muna tayo, grade 11. Okay. Susulatan niyo ang bawat isa. Okay. And then punta tayo sa grade 10. Maybe let's allow 5 minutes for you to form a group of 2 or 3. Okay, as long as may isang grade 11 sa 1:2. Hindi, so meron tayong mga couples, meron tayong mga trio. Okay. We're gonna give you the liberty to pick. Okay. Okay, 5 minutes, please. To our friends sa Zoom, if may kakilala, I'm gonna leave it up to our teachers there and also the students if you want to reach out to somebody to work with you, or if you want to continue working individually, that's okay. Yes. We can do that. It could be a combination of both. Yeah.
Also,
ayaw niyong mamili? Okay, ganito na lang. Wait, tayo kayong lahat. Okay? Hanapin ang iyong soulmate. Okay? Alright, sige. So pwede silang mamili, pwede kayong mamili. Okay? Tapos, please sit together. Bilis na po, 5 minutes lang. Sige, go. Hanap na. Sige na, huwag na magkahiyaan. Meron naman kayong mga tawag dito. Sir, Ma'am Jasmine.
How many are you? 9. Okay, let's use numbers to figure out.
Hindi, kasi in life you should take initiative too, okay? Dapat, diba? Go, if may kailangan kang kunin, kailangan kang piliin, kailangan mong bilhin, go for it. Kasi pag naghintay ka, baka mawala at makuha ng iba. Alright, sige. Let's count. 1, 2. Okay. All right, let's count 1 to 9. One. Okay, all one. O sige, sama-sama sa isang part. 2. 3 to 9, go. Find your group, please.
This is also problem solving.
It is, huh? Oh, okay. So yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9.
All right, so this is one of the questions from the worksheet I'm gonna provide later. It's similar to what we did before. And on the worksheet, I also give you the equations you'll need. For this one, I just realized that equation is not there, so I apologize. Because the equation used here isn't really a kinematic equation that you will cover in physics. It's more of like a definition. So I'll just tell you now, average acceleration, that's basically, let me explain this. Okay, so given a certain period of time, just like estimate what the acceleration is the whole time. Because basically when you accelerate, like you have a car, right? Let's say you're going 5 kilometers per hour, right? And then after 1 second, you're going 10 kilometers per hour. What's your acceleration in that case? Okay, actually, maybe I'll just tell you. So in that case, your acceleration is 5 kilometers per second, because after 1 second, you're going 5 kilometers per hour faster, right? So, wait, sorry. Let's just use meters per second. So, for example, you have a car going 5 meters per second, and then after 1 second, it's going 10 meters per second. It's 5 meters per second squared, because in 1 second, after 1 second, you go 5 meters per second faster. Does that make sense? Okay, cool. But now let's say 1 second later, let's see, you're going 20 meters per second. What's the acceleration here? $10 meters per second squared. So if I ask a question like this in 3 seconds, how fast am I going? It's hard to answer exactly because your acceleration can change. What this question asks is asking with average acceleration. It's asking you just approximate it. So the way we do that is we take the starting velocity, v0, and the final velocity, the final, and then we just use that information to figure it out. So even if it was 5 meters per second squared here and 10 meters per second squared here, let's just pretend we don't know all this. Let's just pretend we only know we started at 5 seconds and then we ended at 20 meters per second. The equation to figure that out is the same as the equation to figure this out. Just pretend you didn't see this. So in that case, I never actually gave you an equation, but you can think of it as, okay, so the equation in that case would be, okay, it is G final minus V0 over time. The reason it took me a bit to get that was because I do it intuitively now. I don't actually read that equation. So, but, okay, so let's put it to a vote. Raise your hand if you would like to work on this in groups and then talk about this after a few minutes and see if we all have the same answer. Or if you'd like me to go through it and then you each work on each step as groups. Does that make sense? So the first one would be, you all would do the entire problem as groups by yourself, and then I would just go around and see what's happening. Or I would go through guess on the board, but I'll ask each of you all to do it in your groups and then let me know what you think. Which would you? Second one, anyone else? Does anyone want the first one? Okay, we can do the second way. Sorry, if did anyone say first option and I just didn't hear it? Can you raise your hand if you'd rather do it the first? Okay, that's fine. All right, so let's just use guess again. So what are we given? And yes, feel free to follow along in your groups. So what information are we given? Yes. Okay, good. It accelerates from 3 meters per second to 12 meters per second. So can we break that down further? Can we just write it as this equals this? So we look at this equation. What's v0? What's the starting velocity? 3. Good. So v0 equals 3 meters per second. Okay. And then what's 12 meters per second? Final, right? Yeah. The final equals 12 meters per second. Okay. And then do we have anything else? Yes. Sorry. Anything else? No, I think that's everything. Correct me if I'm wrong. Okay, so next, what do we want to find out? So you had an idea? Sorry, what was your name again? Kristen, you had an idea? Average acceleration, perfect. I'm just gonna use A for it. Oh, we actually use this, but that's not important for now. So average acceleration. So that's our unknown. Now, that's not us, sorry. What equation we're going to use to solve it? I gave you the equation. So the equation we'll use is velocity or final velocity minus initial velocity equals time or over time, sorry. Oh, equals average acceleration. Okay. And then we explained why that's the case in this example here. All right, now, substitute and solve. I actually just do it all in one go. So I'll give you a few minutes to work with your groups and substitute and solve. Feel free to come up if you need to see it. If you have questions, just raise your hand. Like I said, I'm not gonna give you the answer. So, besides that, the environment. Just wait. So I'm not sure if most of you are doing this, but does anyone on Zoom have questions about the problem we're doing? You can unmute or say it in chat. Yeah. Yeah. Let's see. So feel free to speak in chat or unmute and speak or just say in chat. Does anyone have questions? Or does anyone have an answer to the question? No. Right? Okay, yeah, 3 meters per second squared. Did anyone else get that answer? Yeah, that's good. 3 meters per second. That sounds good. Does anyone else have a similar answer? It's okay. If you have a different answer, that's not a problem. Did anyone struggle to find the units? Is anyone getting meters instead of meters per second squared? Okay. Okay. If anyone else has questions, please just message in chat. I will come back in a bit to check. Okay. Meters per second squared. You. Okay, same thing. This group. Same thing. You three. Same thing. And then back here. Same thing. Okay, good. So we all have the same answer. Let's see. I'm gonna solve it this time. Let's see what I would get. Let's see if my answer would match yours. So substitute. Yeah, substitute. You get the final is 12 meters per second. And, oh wait, yeah. And then minus v initial is 3 meters per second over the time, which is 3 seconds. Let's see. Okay, 12 minus 3. So 12 minus 3 meters per second, that becomes 9 meters per second over 3 seconds. And let me slow down. Divide that. So actually, I'll say that later. So 9 over 3 meters per second squared. I get 3 meters per second squared. Okay, same answer. Good job. So, real quick, I noticed a common error along, I don't want to say error. It's not that you did it wrong, but I noticed something that you all thought that kind of drove you, confused you a bit. A lot of you, and I already explained this, but let me just go over it again. When you did this part, you actually canceled the S. So your answer was 3 meters. Can you raise your hand if you thought that at first? It should be a lot of you. It's fine. That happens all the time. Especially the way I don't know if you're just copying the way I write it, but some people, I purposely wrote it this way this time, because when you write it this way, you sometimes forget that this is a fraction. So similar to most fractions, let's see, we have, let's say we have 2 over 5. How can I write that differently? I can also write it as 2 times 1 over 5. So dividing 2 numbers is the same as multiplying the numerator by the reciprocal of the denominator. So the same thing can be done with units. If we have meters per second divided by seconds, that's the same thing as saying meters per second times 1 over seconds. And that is meters per second squared. I also noticed a lot of you, when I came around, I didn't have to point this out. A lot of you actually asked me, why don't the units line up? So a lot of you were doing unit tests, which is really good. So you all noticed that meters is not the actual unit for acceleration. So really good. But yeah, that's critical thinking skills. And this is less of a problem solving technique, more of just a math thing. And believe me, it's fine. It's a simple mistake, but I make it too. So I don't blame you for that. It's totally fine. But yeah, really good. We have 5 minutes. Do you want to just break early? Yeah. Yeah. Thank you. And feel free to come up to you with any questions if you like.
Okay, attention everybody. Hello. So I know you have your lunches packed, or some of you are going to buy lunch outside. Maybe it's a similar situation for folks in the sister school. Just please remember that we will start at 1 p.m. sharp. Okay, so please be back here at least 5-10 minutes before that. Okay, and then as usual, if you have any questions that came up to you, while you're eating, food is life. It gives you inspiration. So when the questions pop up, write them down, and then we can maybe have some 5 minutes for Q&A.